I am Mr. Ashish Dattatreya Chaudhary, Assistant Professor of BPM's Maharishi Parshuram College of Engineering. In our lecture series, Power Engineering, we are going to start a third lecture on steam generators or boilers. So, in previous lecture, we have seen the steam generator of the type of fire tube boilers. Now we see the water tube boilers. So, water tube boilers. So, basically, water tube boilers means when the evaporation process, if water will be flow through the tubes and flue gases passes surrounding to these tubes, such type of boilers are called water tube boilers. So in that, the first type of water tube boiler is Babcock and Wilcox boilers. So here, if you see, the top is a drum. In that we will feed the water, and this is the water tubes circulated through the headers from the drum due to the natural circulation, and bottom of that, of one side of this total assembly, there is a furnace. So is in the furnace, this is a grate. Over the grate we will burn the coal. Whatever thermal energy generated in the terms of passing of the flue gases, that flue gases will be passed over these water tubes, and this will be circulated due to the passage, through the passage, and it will be taken out from the chimney to the chimney. So here, now we'll see some parts of this boiler. So main, there are the three parts. The first is drum or the shell where water is feeding. This is the water tubes, and third is the furnace. Okay, uh, except of these three ones, so there are some mountings and accessories of the boiler. So first we'll see, so here is the ash pit. So from the ash pit we will collect the ash, whatever it is generated due to the burning of coal, and this is smoker, or this is some of the device is used to flow the air into the furnace to rapid burning of the coal or the fuel. Now here, this is the door. So this door is used to for the maintenance and cleaning of the boiler. These are the headers. uh, in the headers the water tubes are attached. Now here, the feed water inlet. So through that inlet, we will feed the water into the drum or the shell. So this is water level indicator, which shows the how much water is available inside of the drum. So pressure gauge for the indicating the pressure generated into the steam, into the shell. Then the safety valve, then stop valve. So these are the safety devices of the boiler. So this is the manual for the cleaning of the drum. Then this is superheater. So superheater is required to increase the temperature of the steam generated into the drum. That steam will be passed through the superheater, and this is this. So here in the superheater, the heat energy will be taken absorbed by the steam from the flue gases. Okay. Now here, this is the blow off cock. If you consider some sedimentation available into the boiler or the minerals, so that will be taken out from this mud box to the blow off cock. Or sometimes we will remove all the waters or the empty, to require the emptiness of the boiler of the drum. Then you will use this blow off cock. So this is a damper. So damper is used when flue gases will be circulated through this damper or this tank. So this is about the Babcock and Wilcox boiler arrangement. Now, some of the points of the Babcock and Wilcox boiler, the constructional features. It consists of welded steel high pressure drum mounted at the top. Drum is connected with the uptake header and downtake header to circulate the water through the tubes. Water tubes are connected to the headers are inclined at 15 degree to the horizontal. Motor box to collect the sedimentation in the water, we have already discussed. Superheater tubes to enhance the superheating of the steam. Then vents provided on the drum for the safety walves, pressure gauges, water level indicator, visible plug, and recheck valve. It has evaporating capacity ranges from 20,000 to 40,000 kg per hour. So it has a large capacity if you compare about the fire tube boilers. Okay. Operating pressure range from 11.5 to 17.5 bar. So this is low pressure boiler. Steam formed from such boilers are primarily used to run steam turbines and generate electric power, because there is a large amount of steam will be generated with desired pressure. So that steam you will use for the power generation purpose. Okay, so this is the main application of the Babcock and Wilcox boiler. Now here is some comparison between the water tube and fire tube boilers. So first point about the water tube boilers: water passes through the water tubes, and fire tube boilers, hot gases passes through the flues. So this is the main difference. Then steam capacity for water tube boilers is low, and fire tube boiler steam capacity is higher. Complexity in design requires quick examination by skilled hands, and here simple and rigid construction, hence greater reliability and low operating cost. Water tube boilers higher operating pressure, in fire tube boilers lower operating pressure. Evaporation rate ranges from 20,000 to 50,000 kg per hour, and for a fire tube boiler is 900 kg per hour or 9,000 kg per hour. Increase heating surface area. So in fire tube boilers, low heating surface area. Then low water to steam ratio. So in the fire tube, large water to steam ratio. In water tube boilers, bigger in size, suitable for large power plants, and fire tube boilers, smaller in size, used only for small power plants. Transportation and installation is difficult due to large size of shell for the water tube boilers, and transportation and installation is easy due to handling of the dismantled parts of the fire tube boilers. Externally fired boilers, furnace size can be varied. So this is the point of the water tube boilers. And fire tube boilers, internally fired boilers, furnace size cannot be varied. So this is fixed one. And water tube boiler requires more floor area because its size is so much large, and fire tube boiler requires less floor area. So this is the main differences between water tube boilers and fire tube boilers. Now some essentials of a good boiler. The first one, heat generation capacity should be at the first one, required pressure, then second one, required quality, fast speed, minimum fuel consumption. So first one, if you see about the required pressure, so whatever pressure will be required for power generation, so that will be delivered by this boiler. Okay, this is the main. Then required quality. So what about the dryness fraction? If you consider about the dryness fraction, and we will require the dryness fraction of steam will be uh, nearly equal to 0, and such such steam, or you can say superheated steam, will supply to the power generation only. Because if you consider about the steam contains some water, then it will be used, what its effect will be on the steam turbine, that there will be corrosion will be occur. So to avoid that, we will require the a good quality of steam. Then fast speed. So steam generation rate will be higher. We require the steam generation rate will be higher for the boilers. And many essential is that minimum fuel consumption. Obviously, to increase the efficiency, we have the point to minimize the fuel consumption. So this is the main essential of the boiler. And in economics, if you consider, it has low initial cost, low installation cost, low operating cost, and low maintenance cost. Now about the construction, it should be light in weight, it should be less amount of brick work. So if you reduce the brick work, then we can easily more mobile this boiler, or we can carry this boiler anywhere. So if you increase the brick work, its weight is going to increase. Okay, then occupies small floor area. So basically, if we it should occupy less area, then it will be efficient. Then quick starting. So many of the boilers will starting require some large time, and that's why these are the disadvantages. So we will require that the boiler should be a quick start, capable to meet fluctuating demand of the steam supply. So sometimes, according to the load, the power generation demand will be fluctuating, and due to that, demand of this steam requirement also fluctuated, and that means uh, this boiler should capable to meet fluctuating demand of the steam supply. And last point is easy availability of spare parts. So obviously, if any part will be damaged, then it will require in a short period of time. So that means we require essentially that easy availability of spare parts. Okay, so thank you.